Hello, Chemistry, Mr. McKee here, and I'm going to talk you through how to draw three-dimensional models for molecules. So the first thing I want to look at is what we did in our last assignment. We learned about something called VSEPR theory. It stands for valence shell electron pair repulsion theory. And this is basically just an idea that describes the fact that electrons, since they are negatively charged, repel each other. And so they're going to position themselves in such a way as to maximize the distance between each other. For example, we have a model here of what could be a water molecule, where we would have oxygen in the middle here, and then two hydrogens down here. And then we have two of these lone pair electron clouds up here, okay? And all those electrons, whether the bonding clouds, and I'll label the bonding electron clouds here, and the lone pair electron clouds, all behave the same, and so they try to get as far away from each other as possible, and that's how we get this 109.5 degree angle here. So that's the first thing to understand, is that the thing that drives the shape of the molecule is to maximize the distance of the electrons from each other since they repel each other. So that's kind of a summary of our most recent assignment. Now today, we're actually going to use a reference sheet to draw three-dimensional models of some of these molecules. So let's take a look at the steps here that you're going to be following. And the first thing to note is you want to get a blue reference sheet from me. And it looks like this right here. Okay, so make sure you have one of those. That's going to be critical to doing this. So step one is you're going to draw the Lewis dot structure of the molecule, and that's something we've been working on here recently. If you can't do that, the rest is going to be pretty hopeless. So make sure that you're good on step one. And if you're not, talk to me or watch some of those videos that I've posted recently. Step two is you're going to count the number of bonding electron clouds and lone pair electron clouds. I'll model for you what that looks like here. Step three is you're going to use that reference sheet that I just mentioned to identify the geometry of each molecule. And finally, you're going to make your drawing. So let's just go through the steps here. Example one is for dihydrogen monosulfide. That is this molecule right here, H2S. So the first part of it is what we've been doing recently. You're going to make the Lewis dot structure. Hydrogen, of course, has one valence electron. There's two hydrogens here, so that's a total of two valence electrons contributed by the hydrogen. Sulfur has 6 valence electrons, and there's one sulfur in this molecule, so that's 6 electrons contributed by the sulfur. That is 6 valence electrons. That gives us a total of 8 valence electrons. Sulfur, hopefully it is obvious to you, goes in the middle because there's only one of them. I start by assuming single bonds here. I've used 4 of my 8 valence electrons, leaving me with 4, and then I add those to complete the octet for any atoms that need them, and that is sulfur. So we got 2 lone pair electron clouds there on the sulfur. Unshared is another word for lone pair electron clouds. Okay, so once you've drawn the Lewis structure, we're going to come down to the 3D drawing, and the first thing you should do is total up the lone pair electron clouds and the bonding electron clouds in your Lewis dot model. So that's what I'm going to do here. First of all, the lone pair electron clouds, that is these ones right here that are unshared on the central atom. And we only care about electron clouds on the central atom because those are the only ones that are going to influence the shape of the molecule. So we've got 2 of them there, as you can see. Next, I'm going to count the bonding electron clouds, that is the shared electrons. And you see that we've got 2 bonding electron clouds in this particular molecule. So I've got 2 of each. Now I'm going to go to my reference sheet, and I'm going to find the one that has 2 bonding clouds and 2 lone pair electron clouds. And that is going to be in this row right here. And the example compound that has this shape is water. Notice that the Lewis structure of water here looks very similar to the molecule that I just drew. So we see here that a molecule like this is going to have a bent shape, and this is what it's going to look like right here. And you see why it's called bent. It kind of looks like a boomerang there with oxygen in the middle. So now I'm going to go back and I'm going to make my drawing look like water, but I'm going to substitute those other atoms in for it. So sulfur is going to go in the middle where oxygen was in the water molecule. And then I'm going to put these 2 hydrogens down here. There's the bent part of the molecule. And then up here, we're going to have my 2 lone pair electron clouds. And that is the 3-dimensional structure of dihydrogen monosulfide. Okay, and once again, the name of that geometry is bent. Okay, moving on to example 2, which is phosphorus trichloride, PCl3. Step 1 again is to make the Lewis dot structure. Phosphorus has 5 valence electrons. There's 1 of them, so that's a total of 5. Chlorine has 7 valence electrons. There's 3 of them, so that's a total of 21, giving us a total of 26 valence electrons. Since there's only 1 phosphorus, it goes in the middle. We begin by assuming 3 single bonds, and so we've used 6 of our 26 valence electrons. And now we're just going to start adding electrons to complete the octet of all of these atoms. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and my last 2 are going to go on phosphorus to complete its octet. So that's a Lewis dot structure for phosphorus trichloride. Now I'm going to total up the lone pair electron clouds. And I'm only going to total up those that are on the central atom. And that's only 1 lone pair electron cloud. You'll notice that the chlorines have lone pair electron clouds, but we don't care about those because the chlorine is not the central atom. So that's 1 lone pair electron cloud. Now I'm going to total up the bonding electron clouds on the central atom. And I have 1, 2, 3. So I'm going to go to my reference sheet, the blue handout that I gave you guys, and I'm going to find the row that has 1 lone pair electron cloud and 3 bonding electron clouds. And we see those numbers right here. So this is going to be my reference row. NH3, ammonia, is my reference molecule. It's going to have a pyramidal shape. And the drawing is going to look like this right here. So you understand how these drawings work. Again, we're trying to show a 3-dimensional shape on a flat piece of paper. So this wedge right here is trying to show that that particular hydrogen atom is coming out of the page towards you. And then this dash line right here is trying to show that that particular atom, that hydrogen, is going behind the page. And then this hydrogen right here is in the same plane as the page with the nitrogen. Okay, so let's go see if we can draw that. Takes a little bit of artistic skill on this, but not too bad. So we've got phosphorus in the middle, and it has a lone pair electron cloud on top of it. And then we've got one chlorine off to the side here in the same plane as the page. We've got one chlorine coming out towards the viewer of the page. And then we have one chlorine over here that is going back behind the page. And that is the three-dimensional model for phosphorus trichloride. And its shape is like a pyramid, so we say it is pyramidal. Okay, give the U-tries a try. You can pause the video while you do that. All right, welcome back. Here is the U-tries. I'm not going to talk you through all this, but please let me know if you have any particular questions. But we have, first of all, the Lewis structure for these two molecules there. And then if we extend down the page, these are the two three-dimensional drawings. We have one that is linear on the left and one that is bent on the right. One thing to notice in these drawings is that we never bother putting the lone pair electrons on all the outside atoms. We only show the lone pair electrons on the central atoms, which in the case of that molecule is oxygen. So as always, please let me know if you have any questions, reach out, and I'll do my best to help you out. Thank you for watching.